So let us look into a session on reduction in ash of PCI coal. Today we are not just looking at coal, we are looking at the fundamental optimization of blast furnace replacement ratio, we can say. So we are going to explore how minute change in raw material chemistry translate into massive gain in operational efficiency and and economic performance also, we can say. So let's dive into why we inject coal in the first place. So let us focus on the strategic role of the PCI. What exactly stand for? So PCI coal injection is the is, we can say, in other word, it is a heartbeat of the modern iron making. So our goal is clear. We have to replace expensive metallurgical coke, slash the overall fuel rate, and gain the production flexibility. We need to stay competitive also by doing all these. Uh, so by optimizing PCI, we are not just saving money, we are significantly lowering the carbon footprint of our entire plant also. And in this context, the role of pulverized coal injection is going to be immense for any blast furnace operator. So each one of us try to run the furnaces with a higher coal injection, provided with the compatible replacement ratio that need to be evaluated all the time. Otherwise, it is a wastage. So, but we have to see that process are often which having got a ash content and which dictate our maximum injection level also. So first of all, that what is the ash and how minimum ash is there, that we need to see. We need to see that actual balance of the VM and carbon availability should be there to have a maximum combustion efficiency. So that is a delicate issue, and this is out of context of discussion in this presentation. So let's discuss later in some other presentation. So as we can see, the primary effect of ash reduction. So when we talk about reducing ash, we are talking about four pillars of furnace health. That is the higher energy, reduce slag, improve craft, and better burnout. So these need to only revise, and I think each one of us is well aware about all these. A short of a revision, and to many of the colleagues, those who have requested from the institution to talk about these, I'm just I'm just focusing some light on all those fundamentals. So by stripping out the inert ash, we are directly replacing dead weight with the reactive carbon and hydrogen. So these ensure that we are not wasting thermal energy. The melting stone when we should be reducing iron ore. So this lead us directly to 1:1 energy rule, and that is we are going to discuss in the subsequent slide, is 1:1 rule. Here is the beauty of the chemistry. Every 1% reduction in as typically yield almost 1% increase in effective carbon content. So we need to aid in memory these generic lines. So this shift is the primary engine behind an improved replacement ratio, which is also denoted by RR. So more carbon and hydrogen per kilogram of injectant means we can displace more carbon at the top of the furnace, creating a leaner, meaner smelting operation. Now coming to our next slide, which is about slag chemistries and acidic oxides. And now let's look at a chemistry of the melt. Coal ash is a cocktail of acid oxide, especially silica and alumina. These acids are the enemy of your slag basicity targets. To neutralize them, you have to add basic fluxes like limestone or dolo, or you have to incorporate in our these ready-made fluxes in the sinter or palette. So by reducing the ash in the source, we stop the problem before it starts. So which brings us to the incredible multiplier effect of slag reduction. Now coming to the multiplier effect on the flux balance. This is where the math gets exciting. Total slag volume doesn't just drop by the weight of the removed ash. It decreased by 2.5 to 3 times the weight of the removed silica. Why? Because as silica leaves, the flux requirement drops proportionally. That we have to aid in memory. We are removing the need of both the dirt and the cleaner, so leading to a massive reduction in total liquid load of the furnace. So as you can see the raceway dynamics and the burnout efficiency. So in this, let us move to the tour and raceway. High ash level are notorious for the encapsulating coal particles which act as a barrier for oxygen reaching the carbon core. So by lowering the ash, we ensure faster, more complete gasification within very limited residence time of the raceway, and this prevents unburnt uh, char from the clogging the lungs of your furnace, ensuring smooth gas flow, and which is also important to do that. So technically, coming to a technical calculation which is just in the preceding slide, step 1 is the replacement ratio shift. So let's put some number to this theory, starting with a baseline of 200 kg per ton hot metal injection. A 1% ash reduction moving from 9 to 8% gives us almost 1% increase in carbon. So applying a replacement ratio shift of 0.01, we calculate an immediate coke saving of 2 kg per ton of hot metal just from the energy improvement alone. But we are not done yet. So we can see the technical calculation behind this, that slag and thermal balance, considering the slag and thermal balance. Now we factor in the slag removing 1 kg per ton hot metal of silica, resulting in 2.8 kg per ton hot metal reduction in slag. So using the metallurgical rule of thumb, where 10 kg of slag equals zero point 0.7 kg of coke in thermal energy balance, this gives us an additional 0.2 kg per ton of hot metal coke saving. So it's a multi-front victory for our thermal reserve. The 19.8 tons milestone is all about consolidating the saving. So when we consolidate these wins, we hit a total saving of around 2.2 kg per ton hot metal per 1% as reduction. So for a modern 9000 TPD furnace, that equates to 19.8 tons of coke save every single day. That's nearly 20 ton of coke that stay in the silos rather than being burned, drastically impacting our daily OPEX and bottom line. So we can say a strategic let us focus on the strategic macro impact, uh, that is on the productivity and OPEX. So the strategic takeaway are profound. Lowering coke rates translate into multi-million dollars and annual saving. So furthermore, reduced slag volume dramatically improves furnace permeability, and this allow us to push higher blast volume and achieve record-breaking hot metal output without hitting pressure limits. So it's a win for accountants and the operators alike. Now coming to the stability and environmental situations. So in conclusion, we can say that the ash reduction is about operational stability and sustainability. We achieve consistent flame temperature, that is a raft, minimizing the raceway blockages and significantly reduce the carbon footprint of our coke ovens. So we can say we have a cumulative benefit uh, while doing a minor change in reduction of ash of PCI coal.